IM.L1.4-01. A common practical joke is to pull a seat out from under someone as they attempt to sit down. The person falls to the floor and nobody has fun. Assume this happens to a 65-kilogram person. They fall 0.48 meters and it takes the floor 0.078 seconds to bring them to rest. So part A is saying find the impulse acting on the person by the floor. For part A, let's just write down everything we know at first. We know the mass of the person is 65 kilograms. We know that the acceleration due to gravity is 9.8, which we're going to keep positive. We're going to treat downwards as positive. And we know that the change in x downwards is 0.48, so that's going to be positive as well. And we know that the change in time equals 0.078 seconds. And that's after they've touched the floor to when they come to a complete stop. Okay, so this problem can be broken into two parts. The first part, I'll draw a diagram, is when the person is just about to sit and they are falling all the way down to when they first hit the floor. So their initial velocity is 0 here, and their final velocity is some unknown value. We don't know that yet. And then the second part of the problem is once they've hit the floor, they're here, boom. So when they first hit the floor, their initial velocity is some unknown value, we don't know, and their final velocity is 0. So that's what this change in time is about, is the time it takes for their final velocity to become 0 once they hit the floor. So for part A, we have to define what impulse is. So impulse is change in momentum, and J is impulse and P is momentum, and P equals mass times velocity. So since the mass is unchanging, we can just say that impulse equals mass times velocity final minus mass times velocity initial. And that's for this segment. Mass is unchanging, so we know that's going to be 65 kilograms. Velocity final is going to be 0 for this segment here. And mass again is going to be 65 kilograms. And we don't know what the initial velocity is. That's this question right here. But it turns out that this is the same as this value because these two segments of time are in succession. And cross this out because we know it's 0 and rewrite this as impulse equals mass times initial velocity for the second segment. So how do we find this initial velocity? We can do that with this kinematics formula. Velocity final squared equals velocity initial squared plus 2 times acceleration change in x. And we know all of these values except for the final velocity here, which is what we're trying to find. Velocity final equals square root of 0 squared plus 2 times 9.8 times change in x, which they've told us is 0.48. And all of that comes out to 3.067. That's the final velocity, so that's in meters per second. And after that, we can just plug that into here. So J equals 65 times 3.067. That comes out to 199.4. And since that is change in momentum, that's going to be in kilogram meters per second, or also Newton seconds. They're the same thing. After you get that answer, part B is pretty simple. Square it here. Part B asks us, find the average force acting on them by the floor. So this is where we use the second definition of impulse, which is that J equals net force times change in time. So this is average force acting on the object, which is a person, over this change in time, which is the time that the person is in contact with the floor. So this is why we couldn't use this in the initial part A, because we didn't know this average force to find impulse. So all you have to do is plug in 199.4 equals net force, or average force, times 0.078, and that gives you 2,556 about, and since it's a force, it'll be in newtons. That's the answer to part B. Thanks for watching.